All right, this is one of two videos I'm going to be doing on the washer method. So we're going to start with a fairly basic situation. Once again, we're dealing with a volume, a solid. We're going to find the volume of a solid formed by rotating a region about a particular axis. So in this one, we're going to start with rotating y equals square root of x and y equals x squared, that region. We're going to rotate that about the x-axis. So let's get a look at what that's going to look like. Once again, not necessarily the best at drawing these, so bear with me. Okay, so we have y equals the square root of x, so that looks like this, and then y equals x squared, which looks like this. So let's label those so we don't forget. So y equals square root of x, and then y equals x squared, okay? And those are going to intersect at the coordinate 1, 1, and 0, 0. Okay, so this is a pretty basic shape here. So now this is the region that we're going to be dealing with here. So in this video, what I want to do is leave this fairly basic, and we're going to rotate this about the x-axis. So if we can kind of visualize what this thing's going to look like, on the outside, it's almost going to be, it's not, but on the outside it almost is going to look like it is a, like half a hemisphere, okay? And then inside it's going to have this hollowed out shape. So you can't see through it, but it's going to be kind of like this, maybe a fancy lampshade or something like that. Okay. Okay. So and then, so this would be the interior has this sort of hollowed out shape, and then inside, or on the outside, it looks pretty solid. It looks like a, like I said, a hemisphere. Okay. So now we want to find the volume of this thing. All right, so similar to what we did with the disk method, we're going to slice this thing up into, use a different color here, we're going to slice this up into an infinite number of cross sections here. So imagine if I slice this up here, okay, and brought this out. Now the difference here as I rotate this around is before I had a solid disk. Now what I have is I have a disk with a hole in it. So we refer to this as a washer. So like a washer from the hardware store. Okay, if you don't know what a washer from the hardware store, it's just a little flat metal disc with a hole in it. And that's why we call this washer method. So this is our cross section here, if you can visualize this. And wherever I cut this thing, I'm going to have a shape that looks like that. Depending on where I cut this, it's going to have a different size hole or a different size outer shape. Okay, so let's think about what we're going to do here. And once again, we're slicing this up into an infinite number of these washers. So once again, we go back to this idea of the thickness of this washer being dx. Okay, the infinitesimally small change in x. So once again, sort of the closest number you can think of to 0 without actually being 0, because there's an infinite number of these things. Okay, so now let's find the volume of this thing. And I think we can logically think through that the volume of this thing is really going to be the same as two cylinders. An outer cylinder, right, which forms this outer thing, subtracted by a hollow cylinder. Okay, so what we're going to refer to this as is we're going to call this outer thing, the radius there, big R. And this little radius, for the hollow part, we're going to call that little r. So the volume of any one of these is going to be pi big R squared dx. Okay, so that's going to give us the volume of the whole thing, and then we have to subtract out the whole. So that would be pi little r squared dx. Okay, so that is going to give us one of those things. Now, just a couple things I want to point out, obviously, is that dx is in both of those, so we're going to factor that out. You could actually do this as two separate integrals. It's just not what we typically do, but it certainly works. So basically I'm going to bring the pi out, okay? And I'm going to get r, big R squared minus little r squared, and then dx. So that's going to give us the volume of one of these washers. And then to find the entire shape, we're going to integrate from A to B. So this is the formula for sort of any given washer. Let's clean that up a little bit so you can see it. Okay, so this is our general formula. Okay, so now what I'm going to do is I'm going to think about this situation, what's going to be here. So this is a pretty basic one, like I said. So what I realize is this is going to be our outer radius. So our outer radius in this case is just formed by square root of x. Our inner radius is formed by x squared. So we'll call that little r. Okay. So from there, we want to just find our a and b. So where are we starting to find this? So that would be 0, and we're going all the way to 1. So this will be pi, 0 to 1, big R squared minus little r squared. And that is going to give us our volume. Now, if this was, let's see, would this be, this one actually could be closed calculator. I think this isn't too bad to find because we're just going 0 to 1 here. For this particular problem, let's just go ahead and grab the calculator and use Math 9. You don't necessarily want to see me do all this arithmetic. We certainly could do all this arithmetic, but it's not necessary. So let's just go ahead and Math 9 it. So Math 9, 0 to 1. Square root of x squared, we can just call that x in our calculator, minus x to the 4th dx. And what we're going to get is 0.3 pi, okay, or 3/10. And let's go ahead and multiply that by pi. So that would be 0.9424. And then always make sure you're accurate to 3 decimals. So these are our two possibilities here. So that is washer method. In another video, I'll do a second part of washer method dealing with what happens if we change the axis of rotation, which makes it a little bit more challenging. Okay.